Here's problem 2912. A straight 10 centimeter wire bent at its midpoint so as to form an angle of 90 degrees carries a current of 10 amps. It lies in the XY plane in a region where the magnetic field is in the positive Z direction and has a constant magnitude of 3 millitesla. What is the magnitude of the magnetic force on the wire? It doesn't really say how the wire is oriented, it just says it's at a 90-degree angle, bent at its midsection. It's not going to matter actually how it's oriented as far as the magnitude of this force. So let's just assume it's going like this. And if it's bent in the middle, then each section is going to be 5 centimeters. So RL on each side is going to be 0.05 meters. And same thing over here. And we have a magnetic field coming out of the board in the positive Z direction. And the value of that magnetic field is 3 millitesla. Sounds good. Well, let's treat this like two separate segments. We got 1 and 2. And if we use the right-hand rule on these separate segments, with the current, if I indicate in this case going to the right and then up here, then the force on this first segment, pointing in the direction of the current and then closing my hand in the direction of the field coming out of the page, I'll end up with a force, let's call it F1, that's going down like this. And then pointing in the direction of the current in the second segment and closing in on the vector coming out of the page, my thumb ends up pointing to the right for this force 2. So these two forces are actually going to end up perpendicular to each other, and we're going to want to find the magnitude of the net force of those two vectors, F right there. So that's where we're headed. The magnitude of F1 is going to be I L B sine theta, and that's going to be I times RL times RB sine 90 degrees. Of course, sine of 90 is 1. So this is going to be equal to the current, which is 10 amps, times the length, 0.05, times 3 millitesla. And this is equal to 1.5 times 10 to the negative 3 newtons. If we look at F2, that's going to be I L B sine theta. Also I L B sine 90. And again, sine of 90 is 1. And these are all the same values. We got 10 times 0.05 times 3 millitesla, and this is equal to 1.5 times 10 to the minus 3 newtons. So the magnitude of these two forces are equal, but F1 is going down and F2 is going to the right, and they're 90-degree angle between the two. So by the Pythagorean theorem, our net force is going to be F1 squared plus F2 squared square root, which is going to equal 1.5 squared plus 1.5 squared square root times 10 to the minus 3. And that is equal to 2.12 times 10 to the minus 3 newtons. Or we could say 2.12 millinewtons is our net force on this wire segment. That's the magnitude of the force. Angle going down at a 45-degree angle as I've drawn it. But 2.12 millinewtons.